Okay, we've saved the best for last. This is where solving logarithmic equations starts to get a little tricky. What we're looking at now is, in the past we've always had logarithms that have had the same base, and it's been easy to just use simple properties to eliminate the logarithms and solve the simple algebraic equation. Now what we've got going on is we're going to actually have logarithms with different bases. Now the example that I've got here on the notes is just another way of looking at a simple rewrite problem that we've done in the past, and showing you how we can actually make that problem have the same base. And so if we take this part of the example right here, we notice that we have log base 1.035. Well, what we're trying to introduce to you here is what we call the change of base formula. I can actually change that to have a base 10, and what I'll do is I'll take the 5 and I'll bring it to the top part, and I'll take the 1.03 and bring it down to the bottom part. And so what we've done here is we've used what's called a change of base formula, and this is actually going to come out to be the same value of 54.4. And of course that's what we've got going on down here. Obviously the base 10 is not written, it's a common logarithm and it's kind of understood. So this is an example of how you can create the change of base formula by using different properties. Now, one of the things that you need to understand about change of base formula, if you look at this concept box, notice it doesn't say that it has to be log base 10. It can be any log base as long as the log bases are the same, and you can use this change of base formula. Now, this is going to come in real handy when we're solving different equations of logarithms that have different bases. And if we take a look at this first example here, you can see we've got log base 3 x minus 6 equals log base 9 of x. And so if we move the log base 9 over to the left side, that would be a little problematic because we wouldn't be able to use log properties because of the different bases. And so what we're going to do here is we want to take the smaller base, log base 3, and we want to use that log base as our change of base property. So right here we've used log base 3 to change the base of log base 9, and from there we have some workable parts. Now what we're hoping is for this scenario to happen pretty regularly, where we have a logarithm that actually evaluates to a simple number, and then we can go from there. And you can follow along in this example. You can see it gets a little bit complex, and then of course we finish with a quadratic and no less an extraneous solution. And so you can see that a logarithm problem like this can be very involved when it has different bases, and it can go many different routes. And so you're going to have to be really on your game and thinking very well to answer these equations. So go ahead and do the best you can. Sample problem number 8. All the tools that you've learned in this unit so far could come into play. So go ahead and try sample problem number 8 and then come back and watch the solution. You can see that the smallest log that I have here is log base 2, and so I'm going to use log base 2, which is simply a multiple of 4 and 16. That's always very convenient. So I'm going to use log base 2 for my change of base formulas. Okay, there you go. And basically, if you followed along as I wrote out each of the steps, you can see that there's not anything algebraically different than what you've learned between Algebra 1 and Algebra 2. It's just a lot of different strategies, a lot of different algebraic properties, all being used on logarithms to come out with a very clean answer here. Alright, so be prepared in class to work some challenging problems like that.